Thank you very much. Mike?
Thank you, Lynn, and thanks for those questions. So hopefully I have some of the answers. Norm and committee, first I'd like to thank you for inviting United Launch Alliance to speak at this public hearing. My name is Michael Gass. I'm the President and Chief Executive Officer of United Launch Alliance. Like many who will be here before you, I share a deep appreciation for the importance of human spaceflight for the American people and indeed the entire world. I also share an awareness that we are in danger of seeing U.S. leadership in space exploration erode for the lack of clear consensus on an affordable, sustainable, and executable plan for United States human spaceflight. So on behalf of the 4,000 women and men of United Launch Alliance, entrusted with the task of delivering spacecraft safely and reliably to space, I want to thank the members of the committee for taking on this task. It will not be easy. My intention today is to share ideas of potential credible alternatives and to encourage the committee to create the forums for appropriate technical evaluation of the options and assess against affordability, sustainability to support our nation's priorities and acquisition approaches for human spaceflight. Let me just once again add my commitment, my personal and corporate commitment, that whatever the committee's recommendations and the President's decisions are, you have ULA's full support for its execution. The constancy and purpose of the nation of a consensus is more important than any company's or individual's ideas. Next slide, please. Joint utilization of flight-proven systems by NASA, DoD, and commercial providers does provide a safe, affordable, and sustainable approach to exploration, leveraging the existing investments and will reduce annual standalone lean costs. ULA is proud to operate 2 state-of-the-art evolved expendable launch vehicle systems which have launched 24 successful missions. These systems are utilized to support our most critical national security space assets and the most audacious civil science programs, including the Lunar Reconnaissance Orbiter that we plan to launch tomorrow afternoon. We have learned over the course of history of developing and operating complex space systems, it is a financially stable program, whether commercially stable or through government funding stability, that enables a strong systems engineering capability that leverages product evolution, that encourages test and flight trial repetition that leads to reliability, innovation, and cost efficiency. Human spaceflight utilization of EELV will only improve the cost structure and reliability for all of our national users and make the entire EELV industrial base infrastructure more internationally competitive. We have also learned that the fixed cost of maintaining and operating launch infrastructure creates a long-term lean and shapes the budget challenges of entire agencies or companies for decades to come. ULA stands ready to support the committee on evaluation of options that would leverage the existing national and private investments made in the EELV system for future human spaceflight. Delta IV Heavy provides a safe, low-cost capability to launch Orion, we believe by 2014, with greater than 20% performance margin. If tasked, ULA working with NASA engineers, the Air Force, and their aerospace support team, we believe the Delta system can support Orion with credible cost forecasts and schedules based on the recent development experience and meet the reliability needs for human spaceflight sooner than any other alternative. Many of the system improvements contemplated for human spaceflight are already part of a planned evolution to benefit our national security missions that we are currently planning and supporting. Further, we believe Atlas V provides commercial crew capability to ISS and potentially even earlier. We have supported several commercial entrepreneurs that found that Atlas 401 well suited for these potential ventures. The challenge was not the technical solution, but closing the business case and the inherent market and venture risk. Further evolution of EELV systems and components provides options and flexibility to explore the moon and beyond. One of the issues I observed from past exploration architecture is the tendency to allow a point design for launch systems lock you into an inflexible architecture. The Atlas and Delta launch systems have an inherent flexibility in their design potential. We have developed evolutionary incremental variants of these systems all the way up to 100,000 metric tons plus for consideration. Not only are there vehicle flexibility, but there's options available for manufacturing, integration, and launch operations to address workforce transition and unique requirements. The ULA is prepared to support the committee with a thorough evaluation of all these options. So let me elaborate on some of these thoughts. Next slide, please. The pictures represent our diverse capabilities of the expendable launch vehicle fleet. ULA is proud of our role in our partnership supporting national programs and cherish the intellectual capital that we are entrusted with that was gained in over 50 years and 1,300 flight experiences that were accomplished by our heritage companies, Boeing and Lockheed Martin, and the predecessor firms that were consolidated over the past decades represent this experience. This intellectual capital for launch is embodied in our current experienced workforce and in the proven systems for engineering and management that we operate today. The recent successful development experience of Delta IV and Atlas V were developed in the last decade. The EELV systems represent over $4 billion of government and private investment that were fielded approximately 4 years from the authority to proceed to their first flight. The key theme I want to emphasize throughout this presentation is the benefit of reliability through the flight trials of that fleet and a robust infrastructure that comes with a sustained business architecture. Next slide. This slide represents a building blocks for exploration, and it represents 3 important parts. First, we believe the nation needs to go forth with an Orion launch capability to have human space capability with a government-provided launch capability. We also think in parallel there must be a commercial crew capability. As I mentioned, the Atlas and Delta are potential, and there's many entrepreneurs thinking about entering that market as well. And it should be done in parallel, and the government should create an environment to support that. And the market that it should have is that support to the International Space Station from 2014 to that 2020 timeframe to give that market an opportunity to mature. And then on top of that, we show the third leg of those building blocks is the heavy lift variants. In the recommendations that we put forth is that it provides time for trade studies on that future architecture. As we're focused on the Orion and the commercial crew getting capability, we have some time to hone the architecture and pick the flight variant that could be fielded to support the mission beyond the low Earth orbit International Space Station. As stated, we think the NASA could leverage the Delta IV EELV system to support the current Orion with a safe architecture, and the time that we outlined on this schedule is equivalent to the time that we put forth for the entire development of 3 different versions of the Delta IV system to its first flight. Next slide, please. We do not pretend at ULA to be the nation's expert in human spaceflight, but we have been involved with NASA in commercial human rating launch studies for the past 8 years. We've worked with commercial ventures, and we are an active participant with NASA on the Ares 1X program. We believe flight experience is key to human rating. Detailed understanding of the system behavior and environments is getting the benefit of understanding your system margins and inherent risks. With the flight experience, we'll be able to develop precise abort criteria with a robust emergency detection system that would fly on every mission, both human and non-human space flights. Non-crewed missions retire the risk prior to that first crew mission. And I put what looks like a ruler on the bottom, but that's actually our flight experience that goes on in parallel with an ongoing development program. And our lesson when we developed EELV to blend that experience of current flight and development expertise is key to that message. Starting with a highly reliable system, addition of the emergency detection system, and leveraging some redundant critical flight measurements, the abort criteria can be developed, and matched with a good crew safety system, we will deliver that safe human rating. Next slide, please. Delta IV Heavy was launched 2 times operationally with 100% mission success. The Delta IV human rating requirements is well understood. I've talked about the EDS. We believe, as Lynn mentioned, a separate launch pad with a separate crew ingress and egress is required. We also will have a good handle on some additional reliability improvements that we would incorporate into the vehicle, and it would be synergistically required with our national security missions. We believe there's greater than 20% performance margin for both the ISS and lunar trajectories that allows us to provide the shaping to eliminate any concerns of black zones for abort criteria. The DoD RS-68 engine upgrade we're currently working on is the enabler that provides this performance margin. Liquid systems of EELV have the ability to create more benign launch and abort environments. The changes to establish the capability are minimum, and the improvements are synergistic. We think we can be available within 4.5 years with credible cost estimates. Next slide. I mentioned in the beginning about concept of operations, and I offer 2 examples. The 2 examples, one is basically the maximum synergy, where we do the human spaceflight utilizing the existing ULA infrastructure combined with the DoD program, NASA science, and our commercial endeavors. That's what we used in those cost estimates that I shared before on the previous slide, is based on example 1. Example 2 is the one that we'd look forward to support and to go into more detail about, which is about more of a separation where NASA has an integrated operation role of some unique infrastructure. And let me elaborate that. But before we do, these are only 2 examples of many different ways that we could approach the problem. And I want to just highlight the example 2 for a moment on the next slide. Example 2 is highlighted here with a map of the United States that has 3 things identified. The smallest dots represents locations of our industrial base, the key suppliers for the EELV systems, critical resources to the success of the program. The larger red dots represent the locations of our ULA facilities, and the yellow stars represent some additional facilities we would recommend in relationship to this approach. The approach that would recommend that we maintain detailed part fabrication and tank manufacturing in our Decatur, Alabama facility with use of a common supply chain from that industrial base that's represented here. We would recommend that NASA establish an engineering leadership team at the Marshall Space Flight Center, which is only about 15-20 miles from our Decatur facility, to make sure they're the focus for the human rating elements and the integration of the Orion vehicle. We believe when looking at the overall constraints and needs of the program, additional area would be required for final assembly of this vehicle. We'd hope it would have the same underlying technical baseline, but providing 2 assembly areas for production rate. And utilizing existing facilities like NASA's Michoud facility is recommended on this slide. The third element is, again, that launch complex, whether it's Launch Complex 37A adjacent to our existing launch complex or utilizing 39, should be evaluated carefully for best operational activity. One of the things we talk about many times when we talk about synergism and this approach is the efficiency of use of resources, and resources typically is about dollars. I want to emphasize the importance of the human capital resource of our nation, and we need to find a way to be able to harness the expertise and find jobs on this program to not only ensure the appropriate transition of that experienced resource, as well as creating the opportunity for the next generation, and this would enable some of those great opportunities. Next slide. We talk a little bit about EELV for commercial human space. Again, we believe the requirements are well understood. We've been working with several of the companies, and they were nice enough to let us use their pictures of their potential spacecraft, and we gave credit for them at the bottom of the slide. I would want to also acknowledge that United Launch Alliance as part of our consent order and our master agreement, we're in the launch vehicle business. We cannot be a provider of that upper staging service. We could provide launch services to companies that want to be the prime for that service and build those spacecrafts. So it's being a merchant supplier of launch, we're capable of working with many teams. We believe we can offer them a low non-recurring opportunity. Again, if human spaceflight is coming onto the expendable launch vehicle, we'd recommend a second launch pad, and with increased rate, having a competitive or affordable cost. Again, as Lynn mentioned, the characterization from numerous flights, both for NASA, the DoD, the intelligence community, and some commercial spacecraft, provides the data to characterize for future flight safety. EELV and the launch vehicle itself is not on the critical path to this activity. We believe we can have the vehicle ready long before the development and qualification of those spacecraft that you see depicted. Again, the challenge for ULA and the potential commercial operators is the non-recurring implementation cost for both spacecraft development and launch vehicle integration, and our EELV recurring cost. We are working with our DoD, NRO, and NASA customers to buy launches more efficiently for government use, and which would enable better value for the potential domestic commercial ventures. Next slide, please. I talked about the evolution of that enables a flexible mission architecture. This is a chart that was started during some studies with NASA back in the 2003-2004 timeframe that we've further honed after we became United Launch Alliance. The original studies were done as two independent program teams. We joked when we were forming ULA that we'd end up with the Franken rocket, and lo and behold, it's coming true that there's best of both qualities that are being integrated in our future evolution. The important messages of this chart is the modularity of the approach, that there's different breakpoints and opportunities for different architectures, that all of the steps have value to all the customers, and that they be flight used on many of our current NRO DoD missions. The first step that we always highlight is the upper stage. It's the area that can give us more performance, more reliability, and the development of a common upper stage with either improved RL-10 or a new upper stage engine is something first and foremost in our roadmap. The areas in blue are things that we could do using the existing launch infrastructure and current engine systems. The orange, which we call Phase 3, represents things that would require new launch infrastructure, and you know the brick and mortar of launch pads, flame buckets, and all the GSC is the expensive non-recurring element, and would need new propulsion systems. The key message for all of this is that there are choices and that there is synergy in its use. Next slide. We believe human spaceflight on EELV could potentially enhance safety, lower cost, by enhancing and leveraging the flight tempo of the existing programs. We also believe we can accelerate initial capabilities to support the utilization of the International Space Station. We can enable, if we do develop those savings, enable those resources to be applied to supporting missions to the moon and other destinations beyond low Earth orbit. We believe the right policy and the right acquisition strategies will stimulate commercial spaceflight capabilities, and we think we have provided options to address workforce transition and the unique operational requirements of human spaceflight. Again, we are prepared to support the committee and NASA with the detailed data for the evaluations. I encourage an open and thorough evaluation of options which will lead to the best solution for the nation, and I thank you for your leadership in doing that. I'd be available to answer questions.
Yeah, thank you very much. I think we have time for one or two questions if folks have them.
I've got one.
Okay, Leroy and then Wanda.
Yeah, thanks very much for your presentation. I was interested in some of the points you made. In fact, in the summary page, you said you were going to enhance safety and lower costs. And I don't know if you saw the morning's presentation from the the NASA folks, but it seems to run counter to what they're saying about their Ares family. I wonder if you could comment on that.
I did not get to see the presentation, and that's fundamentally the comment about open and thorough evaluation. Clearly need to have their expertise of what's in the reliability, their numbers and assessments. The aerospace team has done theirs. To date, all of these studies have been done compartmentalized, and I think just getting all the experts in the room,
Sure.
potentially with the committee's oversight, would get at the heart of some of those questions.
Wanda?
Hi, Mike. You showed a chart that indicated you've got suppliers across the country, and one of the concerns that has been raised to us is about the industrial base. Can you make a few comments about, in your summary chart, you did not address that. Could you say a few words about what the impact would be?
Absolutely. Dr. Austin, thank you for that question, and apologize for omitting it. The number one thing that I talk about, matter of fact, this morning's meeting with the intelligence community and Department of Defense, we were talking about the focus on the industrial base. It really is fragile. It's fragile for many reasons, one of which is the work of this committee. Without the knowledge and the commitment of a human spaceflight, nobody's investing, nobody's basically planning it into their future. We already know about the budget constraints of the nation, spending in Department of Defense, but fundamentally, things are getting really lean in some of those major factories. We encourage the use of expendable launch vehicles as a strategic program. It does have some key needs over the next 10 years, and the nation right now is not even using that capability strategically. We're buying launches one at a time, so we're not able to use EELV to give some anchor tenancy in some of those supplier base and the knowledge for them to either make investments. The other thing that's going on in the supplier base is an overcapacity. We still have a overcapacity in many of our facilities. We have a challenge. As a nation, we love our competition and have lots of competitors domestically. But in this industry, we're dealing is an international competition. We need to make a decision: is our competition the global competitors, or are we looking to compete internally in this nation? If we do that, we're going to dilute our industrial base, maybe by spreading it around to lots of suppliers that don't have enough business to keep the robust processes that you need for space flight.
Thank you.
Do one more question, Bo?
Yeah. Thank you for your terrific presentation, but I have one question that has to do with the mainstay of structural design in human systems that I've been exposed to for many years has been use 1.4 safety factor, structural safety factor. Is Delta 4 and Atlas 5 designed to a 1.4 safety factor? And if not, how would you overcome that, challenge?
The answer, well, you're on the right, and I think we're consistent with all of those activities. And as Lynn was showing in her criteria, those are some of the kinds of criteria you have in those mature systems. We have 2.0 factor of safety and design margin. If it's untested, we use 1.4 and 1.25, depending on its testing environment and some of the different the modes it's in. But clearly, using the industry standards of 2.0 for untested structure, 1.4 for tested, is kind of our mantra. And if we take exception to it, it's noted with risk, and we have the appropriate mitigations on that. So we think our system is well characterized, well understood on those margins, on not only structure, but on every component throughout the system.
Can I throw one more in there?
Okay, one last one.
I'll be quick. Among the industrial-based concerns is what we do for ongoing development capability for large liquid rocket engines. I noticed that in your future growth plan, you've got the potential for putting dual RD-180s on the Atlas V. Have you looked at all at what it would take to do a modern F-1 RD-180, RD-170 class replacement as an alternative to just putting more of those on?
Yes, Jeff, and thanks for that question. The number one issue for spaceflight is, if you will, it's not United Launch Alliance or the system prime, it's our propulsion industry and our propulsion capability. The fact that our nation does not have a LOX hydrocarbon engine capability is a problem, and if there was that extra investment dollar, that is a key resource across the NASA, civil, and DoD that we need to invest in it. From a commercial standpoint, the if you will, the business case doesn't close. The crossover point is great. We have looked at not only domestic, doing it alone, we've looked at joint partnerships, joint developments. You had, I think, Mr. Perminoff on from the Roscosmos earlier. We worked with his team on a potential of kind of an RD 181 joint development activity, as well as other international partnerships. But LOX hydrogen for a first stage booster has been studied over and over again, and it comes out the right answer, and the fact that we don't have a good, robust domestic capability is a problem.
Thank you very much. We appreciate your comments.